Hey guys, waves travel at different speeds. You may have noticed, for example, that if you see you see lightning, you hear thunder later than the lightning strikes because light travels faster than sound. Um, what determines how fast a wave goes? How quickly it gets to your ear, especially with the sound wave. All right. What determines is something called the medium. So, write this down. The speed of a wave depends upon the medium it travels through. That is our mantra about the speed of the wave. If the speed changed, it's only because the medium changed. Well, what is a medium? The medium is a word just describing the material or matter that transmits the wave. So all waves go through something. If I hit the desk, I could feel it on the other side right here. And you could see it on the camera, in fact, that a wave went into the camera and it started shaking. What transmitted that wave? Well, it was the desk itself. The desk itself is solid, and it transmitted a wave. One molecule of the desk hit into the next, into the next, into the next. And the desk is the medium. So the medium is what transmits a wave. With sound, often it is air, when we're just talking normally. Medium, however, doesn't have to be air. It could be a solid, like the desk was, or it could be liquid. If you've ever spoken underwater, you know water can be a medium for a sound wave when you hear somebody speak. Alright, so what about the medium changes the speed of sound? So here's some examples. The speed of sound in air, liquid like water, and a solid like steel. So if you change the phase of matter, that changes the medium, and that changes the speed of the wave. Air is very loosely connected. It takes a little while for one molecule to run all the way over to the other and hit into it. They're kind of spread out, all these molecules, right, in air. So sound goes relatively slow through it because it takes a while for molecule A to hit into molecule B. Water, however, is a lot more tightly packed. Since the molecules are closer together, they transmit waves more quickly because they don't have to run over to the next one to hit it and transmit the wave. A solid, though, isn't just tightly packed. It's so tightly packed, and it's in this very organized fashion. So the wave is transmitted in a very connected medium when it comes to a solid like steel. So solids have the highest speed through them because they're very tense and tightly connected. You may have seen this picture before. You need to draw this. But if you lived in the Wild West and you were trying to hop aboard a train and maybe hijack it, the way you would listen to see if the train's coming is not through the air. You can actually hear it coming first through the solid rail, because sound travels faster through the rail. If you ever walked over the train tracks in Bergen County, you could hear this high-pitched squeal coming from the tracks, meaning a train isn't necessarily close, actually, because sound travels so fast through steel that even a far train might make it rattle and make this high-pitched sound. And you could tell if the train's coming through the solid first because it's more tightly packed and transmits the waves faster than the air. Another really good example is, it's very practical. Here's a string, right? There we go. And this is going to represent my guitar string. Now, look when I pluck it right here. The waves go so fast that you can't even see it. They go back to my hand and they bounce off and come back. You can hear it a little bit. Solids transmit waves so fast you can't even see it. But if you were to look at something like an ocean wave, it takes quite a while for a wave to go through the water compared to a solid like a string, which is more tightly packed and organized in the way it's connected. whereas water just in molecules kind of flow past each other. It transmits the wave very slowly. Another last good example is with the ocean waves. Think about it. If you stand in the water at the ocean, do the waves ever pass each other? Or do they all go at the same speed? In the ocean, I mean, you might have waves going at an angle, but you never have a wave back here overtaking one up here. Because they're all in the same medium, and they all go at the same speed then.